right, section 6.5, prove by side, side, side similar and side, angle, side similar. So our goal today is to use these similar theorems. Now, note, when using these, you have to absolutely use that similar symbol. Because if you just write side, 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 you are proving triangles are congruent. You are not proving they are similar. And that will not be accepted as valid. So make sure when you are doing similar triangles, you are using that similar symbol. So the first one, side, 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 similar. This means that all three pairs of sides are proportional. So looking at this triangle, we would say if, and what we're going to do is match up. So if AB over X U is equal to BC over UW equals CA over WX, then triangle ABC is similar to triangle XUW. So it has to be all three pairs. The other one we look at is side, angle, side similarity theorem. So this is two pairs of sides proportional. And the included angle. It has to be the included angle. Just like side, angle, side for proving triangles, has to be the included angle. Alright. So looking at this one, we would say if CA over WX is equal to AB over XU and angle A is congruent to angle X, then triangle ABC would be similar to triangle XUW. So again, on both of these, you need to be proving sides are proportional. These ones you're not necessarily going to be doing a two-column proof, but you're going to be justifying or using them to prove or say that they are in fact similar. So is either triangle DEF or IHG similar to ABC? All right, this is two problems in one. So what we will do is the first problem that says is triangle ABC similar to triangle DEF. And we're looking here, we don't have any angles. We're looking, all of them are side, side, side proportional. So the first thing I do when doing these is write out the proportion. So AB, BC, CA, and then we're talking DE, EF, FD. Reason being I do this is because if the order is switched in how the problem is presented, I want to make sure that I'm accurate when doing these. And then I'm going to go in and fill out all of this information. So AB is 25, BC was 15, and CA was 30. DE was 15, EF was 20, and FD was 30. I can look at it right away and say this is a big old no for the reason of this one is greater than 1, this one is less than 1, and this one is equal to 1. So there's no way that those are all going to be equal. So right away I know not similar. So DEF was a no-go. Part 2 of the problem is triangle ABC. Similar to triangle IHG. And again, what I'm going to do is I'm going to go in order. I know this is a triple proportion. So AB, BC, CA, IH, HG, GI. And now I am going to copy these from the diagram. Okay, now they're all look to be smaller than 1, so however you like to do these, whether you want to reduce the two fractions or do the two, or I'm sorry, reduce all three fractions or do the two cross multiplings like we did back earlier in the chapter, it is your choice, but I'm going to reduce the fractions, and I get 5/7 in all of them, so yes. Triangle ABC is similar to triangle IHG by side, similarity. Find a value that makes these two similar. Now, there are a couple different ways you can do this. You can make it easy on yourself, or you can make it difficult on yourself. What I tend to do in doing these is go through and identify the matching pairs. So we know that JK and MN are matching. Right there, I know I have a pair where there are both numbers. I'm going to use that pair. But I'm also going to identify a pair with a variable in it. So we have KL and NO. And lastly, we have the JL and MO. So looking at these, they're both expressions. It's just a matter of picking which one would I like to solve for. I'm going to use the blue ones, the x plus 6 and 21, because I don't really want to do this 3 with the x minus 2. You could use it, I just don't feel like using it. So I'm going to say that 20 over 30 is equal to, and again, 20 came on from the left triangle, so the blue value from that triangle is x plus 6. And the blue value of the triangle that 30 was on was 21. And now I'm going to cross multiply. Again, 20 over 30. The zeros cancel, so I have 2/3. I'm going to multiply. Remember, this is as a quantity, so I'm going to have 3x plus 18 equals 42. And then I'm going to go about solving, so I'm going to subtract 3x from both sides, so I get 3x equals 24, and thus x equals 8. And you could have solved it the other way, you would get the same value, it's just a matter of personal choice. I personally look for which one would be easier for me to solve. This last one says you enlarge triangle PQR to STU as shown. Are they similar? When looking at this diagram, this is an absolute mess because there's all these overlapping lines. So what we are going to do is we're going to draw this as two separate triangles. So I'm just going to draw PQR. We know this is AB. That was Q, that was P, this was R. Okay, there's our PQR. And what information do we know? We know that QR is 18. And we know that PR is 16. And we don't have anything about QP. So we have that triangle. And now we're going to draw this other triangle, this STU. And we know this was 80. This is U, that's T, S. Again, we're going to pull away. We have that SU is 24. And TU is 27. So we have this, the black triangle, and this, our green triangle. And we're trying to figure out, are they similar? And again, you could draw this as this overlapping agglomeration that it is, and solve it. By all means, that works. I find it personally easier. So, to start, we have a pair of angles. And we look, it's between our two pairs of sides, so that's the included angles. So yes, that one works. Now the question is, are these proportional? So we will go, is 16 over 24 equal to 18 over 27? And again, you simplify both fractions, which you do, you would get 2/3 equals 2/3. Or if you did the multiplying, you would have 432 equals 432. So that's a yes. They are proportional. So are they similar? Yes, we have two pairs of proportional sides. We have a pair of included angles. So our final answer is going to be yes, triangle PQR is similar to triangle STU by side, angle, side, similarity. The biggest thing with these is to make sure you are, when it says explaining, writing it out. I find you're going to get a lot of these overlapping diagrams. Draw them as two separate triangles, and these problems become much, much easier.